Okay, so in R1, about the only important thing I need to remind you of is please excuse my dear Aunt Sally. It refers to the order of operations in algebraic expressions. PE are parentheses and exponents. You do parentheses and exponents before you do MD, multiplications and divisions. And only after those four are done do you do additions and subtractions. That's the AS. So for example, if I had 4 to the negative 1 times 3 minus 1 plus 4 squared divided by 3 minus 2 cubed, I do the stuff inside the exponent first. That's 5. And 5 squared, 4 to the negative 1, and 2 cubed. I do all these exponents next. 4 to the negative 1 is 1/4. That's 25. 25 divided by 3 is 25/3. Minus 2 cubed is 8. So that's 3/4 minus 25/3 minus 8. Got to remember how to add fractions. So I'll multiply top and bottom of this one by 3, top and bottom of this one by 4. So that these two guys will have the same denominator, that's 12. Multiply top and bottom of 8 by 12. I'll think of that as 8 over 1. So it's a whole bunch of twelfths. Looks like 9 minus 100 minus 8 times 12, 96 over 12. So that's, I guess, negative 196. 196 minus 9, 187. Over 12. So to pick another example that I often see students mess up, if somebody writes, negative x to the 4th, that refers to negative 1 times the 4th power of x. That's not the 4th power of negative x. If somebody wanted the 4th power of negative x, they'd have to use parentheses first, because otherwise the rules say the exponent happens before that multiplication. So for instance, negative 2 to the 4th is negative 2 times negative 2 4 times, right? And then that product is positive 16. But negative 2 to the 4th is just negative 16. In R2, let's talk for a second about the laws of exponents. So a to the n refers to the product of a bunch of copies of a, n copies of a. And then we have this, convention that a to the 0 stands for 1, and if the exponent is negative, like in a couple of examples ago, a negative exponent means a positive exponent on the denominator. So for example, 2 to the negative 3 is 1 over 2 cubed, and 2 cubed is 3 copies of 2 multiplied together, so 2 to the negative 3 is an 1/8. There are some rules for combining exponents. So here's one, a to the m times a to the n. All these rules work when the exponent is positive or negative or 0, but I try to remember what they would mean when all the exponents are positive, because that's the easiest situation to think about. So that would mean m copies of a. And that thing there, and a to the n, would mean n copies of a being multiplied together. So this is a whole bunch of a's. How many? Well, there are m of them there, and n of them there. That must be a to the m plus n. And a to the m divided by a to the n, that's m copies of a on top and n copies of a on the bottom. Let's suppose m was bigger than n. You could cancel off some of those common factors, and you'd be left with some a's on top. That'd be a to the m minus n. In fact, that rule works whether m is bigger than n or vice versa. It's still true that a to the m over a to the n is a to the m minus n. When I take a power of a power, like a to the m raised to the nth power, well, this is m copies of a, and that's repeated n times, so how many a's do I have altogether? if I've got m copies inside this parenthesis, and I duplicate that n times, I've got a to the m times n altogether. Another useful rule is, if you have a product in here, a times b raised to the nth power, think about that. If you wrote all that out, you'd have a bunch of ab, ab, ab. How many a's would you have? You'd have n of them, and you'd have n b's. The order in which we multiply things doesn't make any difference. So ab raised to the nth power is the same thing as a to the n times b to the n. It's also true that a over b raised to the nth power is the same thing as a to the n over b to the n. But here's a warning. A plus b to the n does not equal a to the n plus b to the n. People who write that down are confusing this with this true fact that says ab to the n is a to the n times b to the n. The one thing I remember about laws of exponents are, if the bases are the same, then there are rules that allow me to combine the exponents. Or if the exponent is the same, then there's rules to allow me to sort of combine the bases. Like here, this a to the n and b to the n are both raised to the same exponent, so there's a rule that allows me to combine them. But if I had, say, x cubed times y squared, these guys have neither the same base nor the same exponent. There really isn't a way to combine the exponents. I mean, this can't be written in any simpler form than what it already is in. In R.3, you're going to be required to remember a few rules from geometry. So let's see, there's the Pythagorean theorem. That says in a right triangle, that is a triangle one of whose angles is a right angle, the side opposite the right angle is called the hypotenuse and the other two sides are called the legs. In a right triangle, a squared plus b squared has to equal c squared. Let's look at some other formulas. So there's the formulas for triangles. Let's say the base of that triangle is b, and that height there, that distance is h. Then the area of a triangle is 1/2 base times height. In a rectangle, let's say the width is this horizontal dimension and the length is that vertical one. The area is width times length. The perimeter is just the sum of the sides, the sum of the, well, it's the distance around the rectangle. So that's 2w plus 2l. In a circle of radius r, the area is pi r squared, where pi is that number 3.14 roughly. And the perimeter of a circle is often called the circumference. The circumference is 2 pi r. Then the last thing that comes up a lot in geometry story problems in an algebra class are similar triangles. Two triangles are similar if they have the same three angles. Let's say like this angle, I'll call that triple slash, and this one I'll call double slash, and this one I'll call slash. If I have some other triangle over here, try to make it bigger, with the same three angles, not necessarily, oriented the same way, it may be rotated or flipped around, but if that angle is equal to this one, and if this angle, I'll label double slash, is equal to that one, and if this one is equal to that one, then these triangles are called similar. Because the three angles of a triangle have to add up to 180 degrees, one reliable test for the similarity of two triangles is if they just have two of the same angles, because if they have two angles the same, the third angle has to be 180 minus the sum of the other two, so the third angles would have to be the same as well. But in a similar triangle, sides are in proportion. So if I identify the side that's opposite triple slash angle over here, and over here I'll call this one, let's say, gamma. And let's say the side that's opposite single slash, it's A over in this triangle, but over here it's alpha. And the side opposite the double slash angle, over here it's beta. Then corresponding sides are in proportion. So for instance, A over alpha is the same as B over beta. And that's the same as C over gamma. Or if you like, you could take ratios of sides in this triangle and compare them to ratios of corresponding sides over here. For instance, A over B must be the same thing as alpha over beta. Or A over C must be the same thing as alpha over gamma in that triangle.